Hi everyone, so last video on trigonometry, we'll make this a quick one. So if you remember where we were last time, we were talking about our identities and we were doing mini trig equations with our cast method, wasn't it? So we had all silly tom cats, yeah, where either sine, cos or tan was positive or all were positives, so between 0 and 90, 90, 100, and then, sorry, 19, 180, 180, 270, 270 to 360. We also had our two identities. So the first one was sine squared x plus cos squared x is always equal to 1. That's what those three lines mean, always equals to. So it doesn't matter what value of x is in there, this will always work. So that's why it's called an identity. And also tan x is always the same as sine x over cos x. So if you see we've got this problem here, we've got this 3 minus 3 cos 3x equals 2 sine 2 3x between 360 and minus 360 for single x. So how do we approach something like this? Well, all we can do is when you see a sine squared and a cos by itself, you have an identity here which you can convert it to, can't you? So you know that sine squared plus cos squared is 1. If we get everything in terms of cos squared here, or cos, so cos squared, cos, and a number, then we've got, in a sense, a quadratic that you can factorize, you see? So let's think about it. So what is sine squared the same as? Well, we know sine squared 3x plus cos squared 3x is always equal to 1. So literally it doesn't matter what the angle is in there, as long as the angle is the same. So sine squared 7x plus cos squared 7x would always equal 1. It literally doesn't matter what the angle is, as long as they're the same. We can rearrange that to get sine squared 3x is always the same as 1 minus cos squared 3x, you see? Just bringing that cos squared over. So now you can sub that in to our equation. So 2 and now 1 minus cos squared 3x. And now we can start solving this thing. So this is 3 minus 3 cos 3x is 2 minus 2 cos squared 3x. And now we can bring everything over, so we get 2 cos squared 3x. Moving over to the left, minus 3 cos 3x. And then 3 take 2, x plus 1 equals 0. You see? So it is in the form of a quadratic. To make that even more explicit, you could say let y be the same as cos 3x, you see? So now you can definitely see this is in the form of a quadratic if you let cos 3x be y, you see? And this you can factorize, can't you? So 2y, y, minus 1, minus 1. So you get y equals a half and y equals 1. But we didn't start with y, so we can't finish with y. We actually know that y is cos 3x equals a half, and cos 3x then equals 1. Remember, this is now a simple solve, but we need to make our domain, our range, well, it should be domain, match. So if we're doing it between, oh, actually, sorry, it says here between 0 and 360. So let's do it between 0 and 360 then. So we've got x is between 0 and 360, but we need 3x. So we're going to times everything by 3. So what's that? 1080. So let's first solve. So if we type in our calculator cos to the minus 1 over half, we'll get 60 degrees. And as we know, it's cos, so it's plus or minus 60 straight away. Yeah, from our cast, because cos is positive at 60 and cos is positive here in our cast diagram. Okay, so therefore we plus or minus the period, don't we? So 60 minus 60 obviously isn't in the domain, but we can add 360 to it, so that's 300. And now we'll add 360 to both things, so 60 plus 360, 420. plus 360 is 780, plus 360 is 1000, that's too big. 300 plus 360 is 660, plus 360 again, so that's 9, 1020. Okay, and that's all the values within our domain. So to finish off, just divide everything by 3 and you'll have it. So 140, 780 divided by 3 is 260, 660 divided by 3, 220, and 1020 divided by 3 is 340. There we go, solved. See? So that's how you can build a quadratic expression by using that identity, and then let it equal y, let cos or sine equal y, convert it back, and then it's a normal trig solves. Also, with these identities, we can use proofs, and we can prove that one thing equals the other thing. So here, I need to prove that tan x plus 1 over tan x is always the same as 1 over sine x cos x. So on a proof, you need to literally hold the person by the hand. You have to show them everything. So you make it really explicit. Don't assume that your examiner or whoever knows anything about this. So you need to start on either the left-hand side or the right-hand side. So in this one, I'll start on the left-hand side because I know I can switch tan x into sine x over cos x. As remember, tan x is always equal to sine x over cos x. I see on my right-hand side that I need sine x and cos x's, so I might as well start on my left-hand side. So I'll quote my left-hand side. So I always write whether it's LHS, so that's left-hand side, or RHS for right-hand side. So I quote my left-hand side is always equals to, and now I can start working. So tan x is sine x over cos x, isn't it? Plus 1 over tan x, which is sine x over cos x, which is always equals to sine x over cos x plus, well, 1 over sine x over cos x is the same as cos x over sine x. How can I put these two things together? Well, I need their denominators to be the same. So I would sine x and sine x top and bottom, and I need this one to have a cos x to make them match, so cos x over cos x. So now I've got sine squared x over sine x cos x plus cos squared x over sine x cos x. If you add, now you can add them together because their denominators are the same. So you get sine squared x plus cos squared x over sine x cos x. And what is sine squared plus cos squared? Well, we know that that's the same as 1. So this is 1 over sine x cos x. And this is the right-hand side as required. So there are certain things that you must include within your proofs. This always equals 2 sine, because that is what that is saying you're proving an identity. You started off the left-hand side, you finished with the right-hand side, and then some statement to say you're finished as required. So, I found what it is that you've asked me to find. Notice that I've got a perfectly blank space here, so your layout has to be perfect for a proof. Okay, you can see a perfectly blank space here. That means everything's in the right order, it's in the right fashion. Let's try this again. So number 2 says prove that 1 over sine x plus tan x over cos x is always the same as 1 over sine x cos squared x. Well, again, I wouldn't really start on the right-hand side because there's not much I can do with it. But on the left-hand side, because I've got that tan there and I know I need sine and coses, I can change my tan, can't I? So I quote my left-hand side exactly as it is, and then I can get to work. So that's 1 over sine x plus tan x, which is sine x over cos x, all over cos x. So that's 1 over sine x plus sine x. Now, sine x over cos x, all divided by cos x, is the same as cos x over 1, isn't it? So that means, if I bring it over here, that's the same as sine x over cos x, and the fraction flips up, so 1 over cos x here. So you can see that sine over cos squared x. So just like before, remember my always equals 2, not just equals, need to make the denominator the same. So that's cos squared x over sine x cos squared x plus, and this one needs a sine, so sine squared x over sine x cos squared x. Whack them together, cos squared x plus sine squared x over sine x cos squared x. And we know cos squared plus sine squared is 1. And that is the right hand side as required. So we're finished. And I think we'll have to leave it there.